Me and my group are here to present about the case study for the next gen electric scooter. The first question was, what are the top 10 features would you want in the app for the electric scooter, and explain which are the top 5 features would be most useful and why. So here are the top 10 features: tire pressure monitoring, remote lock and unlock, speed limiter, optimal route suggestion, point of interest like charging stations and parking, security and anti-theft, social sharing like the ride status, maintenance and support, theme option, and group rides for the planning. From here, the top 5 useful features would be vehicle status and diagnostic. This is perhaps the most important feature. Having the actual current battery level and estimated remaining range directly affects the user's capacity to effectively plan their ride and not get stranded. Picture having to go somewhere important and not knowing whether your scooter has a sufficient charge would not be a good idea. Second is the navigation and route planning. Map integration with scooter optimized route planning based on the bike lanes and avoiding pedestrian zones or dense traffic areas greatly improves the riding experience and security. Default car navigation apps aren't always well suited for scooters. Route planning made specially for micro-mobility provides a safer and a smoother trip. Third is the security and anti-theft like GPS tracking, alarm system, geofencing. Security is the major concern for scooter owners. GPS tracking allows users to locate their scooters if they are lost or stolen. An inbuilt alarm can prevent attempted thefts. Fourth is the ride control and management. Remote lock and unlock capability brings convenience and security. Forgetting to lock your scooter physically can be a concern, and remote locking addresses that. Ride mode selection like Eco, Normal or Sport enables users to tailor the performance of the scooter according to the requirements and the conditions for riding, trading of speed, range and power. The last is the ride history and saved location. A customized user account provides for the saving of the user preferences, ride history and most often visited places. Ride history can be utilized for usage tracking, distance traveled calculation and also for insurance purposes. Saving most used location like home and work makes planning routes easier and more convenient. The second question is what are some of the design consideration you would have for designing the storage features, and what all will you need to consider for security of the documents while designing the architecture. First would be the user needs and context, like what documents will the users archive, how frequently are users going to retrieve these documents, what is the technical ability of the user, mobile first design. This will determine the supported file types like PDF, images or etc., and whether or not there may be a need for categorization or tagging. This makes easy retrieval and organization more crucial. The interface must be intuitive and simple to use for everyone. The design should be optimized for mobile, taking into account screen real estate, touch interaction and on-to-go usage. Second would be the technical consideration, the storage capacity, file size and the scalability. Establish the storage limits per user and overall storage infrastructure required. Specify acceptable file size limits for uploads. The storage solution must be scalable to handle an increasing number of users and documents. The third is the access control and authentication. Strong authentication use strong user authentication methods like multi-factor authentication to authenticate users prior to providing access to the documents. Secure session management. Employ secure session management method in order to stop the session hijacking.
So the question is, what do you think are the business metrics which are being used by the company to decide what to focus on for improvements and changes? What engineering metrics and measurements do you think should be looked at considering the complaints from customer? Do also give the reasons for the metrics and measurements you have selected. So, the business metrics likely used by the company. The first component in the metrics is customer satisfaction. Why it matters? It matters because it directs indicator of customer happiness and loyalty. Then, net promoter score. It matters because it measures likelihood of recommendations. Then, retention rate. It tracks how well customers stay focused long term. Then, churn rate. It shows if users are leaving due to poor experience. Then, app rating and reviews. Reflects user experience and product quality. Then, feature adoption rate. It tells which features users love or ignore. Then, cost per service issues. It matters because it measures operational efficiency. Then the recommended engineering matrix. So the first component of recommendation engineering matrix is system latency. The reason to use it is crucial for real-time tracking and responsiveness. Then second component of matrix is API response time and failures. The reason to use it helps detect slow or failed communication paths. Then cloud uptime or availability. Uh, Reason to use is it impacts app reliability and customer trust. Then data sync success rate. It indicates reliability of vehicle cloud app flow. Then battery data accuracy. It ensures trustworthy health and range estimates. Then app crash rate. It measures app stability affecting user experience. Then update success rate OTA. Monitor smooth deployment of improvements. The next question is, the company is collecting the data in the cloud already, but have had performance issues to update. Collect the data and update the app. What can be the reasons for that, and what would need to be improved for the data integration from the vehicle to the cloud and to send the data post analyzed to the app. The issues in this current setup are, first, high latency in vehicle to cloud transmission, then backend or API inefficiencies, then poor database performance. The fourth issue is raw data overload from vehicle, and the last issue is lack of scalability and edge computing. The recommendations to improve data flow are, first recommendation is edge processing, filter or process data on the scooter. The second recommendation is efficient protocols, use MQTT or data syncs. Third recommendation is scalable backend, use cloud auto scaling queues, example Kafka. Optimize database, time series database plus Redis caching. Fifth recommendation is smarter app sync, push updates, background sync.
So the question is, the company would like the app to have intelligence and provide recommendations to the driver. So what kind of data should the app collect from the vehicle, and what kind of recommendations can be done? Is there a possibility to use ML and AI for this analysis, and if so, what can be the use cases? So to provide intelligent recommendations to the driver, the app should collect data such as vehicle speed, acceleration, braking patterns, fuel consumption, engine diagnostic, GPS location, route history, and environmental conditions. Then, based on this data, the app can recommend safer driving speed, optimal routes to avoid traffic or bad weather, then fuel saving techniques, and timely maintenance alerts. AI and ML can be leveraged to analyze driving behavior, predict component failure, then detect anomalies, and personalize suggestions. Use cases include driver score generation, predictive maintenance, real-time risk alerts, and adaptive route planning and based on historical and real-time data. The next question is, use the product solutions concepts and create a mind map for the new version of the vehicle explaining the goals, features, UX changes and UI changes if any you want to target in the scope. So for the smart vehicle app, the product solutioning overview is so goal should be improve driver safety and vehicle health, enable intelligent data-driven recommendations, enhance user experience with personalization, and reduce fuel and maintenance cost. So along with this, the key features are data collection, that is speed, braking, GPS, OBD second, environment, AIML uses, behavior analysis, predictive maintenance, route optimization, and recommendations, safe driving tips, then fuel savings, saving alerts, route suggestions, and reports, driver score, trends, maintenance logs. In UX improvements, then guided setup, smart tips after trips, notification prioritization, voice assistant for key alerts. And in UI enhancements, clean, modular dashboards, trip highlights timeline, health and risk color indicators, and then graphs for performance and trends.
So the first question is, list the potential reasons for any of the issues which the customers have complained about, and write the test scenarios you would use to test and ensure they have been fixed. So the issue 1 is inaccurate battery level display in the app. So the potential reason is delayed synchronization between the scooter and app backend. The battery percentage shown in the app might be outdated due to latency or lag in the real-time data from scooter's firmware. And then to the app, unstable Bluetooth or internet connectivity. The app relies on Bluetooth for direct communication with the scooter or on mobile internet for fetching cloud sync data. If either connection is unstable, the data may not reflect real-time battery levels. First test case is scenario: fully charge the scooter, then discharge it by riding and monitor battery status in the app. Expected result: battery level should decrease accurately in real time. The second test case is scenario: turn off Bluetooth internet while using the app and then reconnect. Expected result: app should resync and show the correct battery level upon reconnection. Test case is compare the battery status shown on the scooter dashboard and in the app simultaneously. Expected result is both values should match with no delay beyond a few seconds. Fourth test case is use multiple devices to log in with the same user and compare battery level display. Expected result is all devices should reflect the same battery percentage. So the issue number 2 is charging station locations not updating properly. So the potential reasons are outdated map integration or static data. The app might be using hard-coded or infrequently updated map data, causing it to miss newly added or relocated charging stations. Backend database not syncing with front-end app. Even if new stations are added by operations team, there might be an issue with how the app fetches that data in real time. So for that test cases, add new charging station via the admin panel and check its visibility on the app map. The new station should appear within a minute or according to sync intervals. And the second is simulate user GPS movement and verify if the list of nearby charging stations update. Charging station displayed should change based on the user's location. The second question is use the inside out and outside in technique of releasing a product to the market and list the top 5 things you would do in inside out planning to release a new app to the market and outside in planning for releasing the new app. So inside out planning, product first approach focuses on what the company believes is best for customer based on technical capabilities, product roadmap and internal vision. The top 5 things to do is first define core product features clearly, build a technically robust infrastructure. Third is conduct in-house testing and QA. Fourth is create internal documentation and training material. And fifth is set milestone for release phases. The outside in planning starts by understanding user needs, behavior and pain points and designs the product around solving these problems. The top 5 things to do is conduct market research and user surveys, create detailed customer personas, simplify user onboarding, gather beta data user feedback, and plan a customer centric launch strategy, which includes referral programs, launch offers, user tutorials, interactive demos, and strong customer support channels from day one.